Okay, this question two, you're given a table of values here. You're given this car, this vehicle starts from rest and accelerates uniformly uh, and travels a total distance of 25 meter. So at t equals 0 is everything, the initial velocity is 0, the power is 0, everything is 0 except the force applied is 2000 Newton. uh, because you actually want to produce an acceleration. Okay, the net force is 2000, so you simply compare this to F equals ma. You find that uh, they are consistent. M is 2, uh, A is 1000, so it's 2000 Newton here. Okay, so the column for F, everything should be constant 2000. So here should be the missing table value here should be 2000 also. Okay, so you're asked to complete the rest of the values in the table. There's one row missing and time t equals to 4. Now the values here can be easily calculated from equations from kinematics, right? So V equals U plus AT. U is 0. So is A is simply 2t, right? 2t. So A is 2 here. So this is 2. U is 0. So it's 2 times of t. So 3 will give you 6, 4 will give you 8. This is quite simple. And then the power, this is the instantaneous power. The power increases. The power increases is instantaneous values given by force times velocity. So this column, the second and third column multiply together. We see that this multiplied by this give you this, right? This 4 times this give you kilowatt. 6 times 2 is 12 kilo. So 8 times 2 is 16 kilo. So it's 16 kilowatt. And the last one is what about the value of x? So it's 16. The value of x, again, this is possible. This is obtained from a kinematic equation. S is ut plus half at squared, right? So this is u is 0. This is our x here. Half a is 2, so it's 1. So it's t squared actually. A is 2, half times 2 is 1, so you're left with t squared. So t equals to 2, you have 4, right? T equals 3 and 9, so t equals to 4 is 16, right? So this part is very easy, right? Next part of the question: what was the maximum power of the vehicle? As you can see from here, the last value here, 20 kilowatt. Okay, that's the maximum power. The largest value is 20 kilowatt. The answer is 20 kilowatt. Okay, kilowatt. What was the average power output of the vehicle? If you see that the column here, this column here for power, and it increases by step of 4, right? 0 to 4. If you look at this table from 0 to 4, 4 plus 4 give you 8, 8 plus 4 give you 12. Increase by 4 kilowatt every second. So if I can plot the graph, this is how the P graph changes with time. We start from 0, this is P, then every second it increases by 4 kilowatt, exactly equal. 4 kilowatt, 8 kilowatt, uh, and 12 kilowatt and 16. So the maximum is 20 kilowatt. Okay, 20 kilowatt at when the time is 5 seconds. Okay, this is 5. Maximum is 5 seconds. Okay, so this is the maximum. So as you can see, the power increases linearly with time. So the average power is therefore from 0 to a maximum of 20 kilowatt divided by 2 here. Okay, so that gives you 10 kilowatt. Okay, so that's the answer um, for this part here. Now, what about the next part here? Um, a vehicle starts from rest and accelerates uniform. It's very similar to what we're doing here, but this time they ask you to plot a graph of power against distance. Now this graph that I drawn above here, this is against time. This is time. Whereas they ask you about distance here. Now actually you can get an answer from the last two columns here. Okay, you can get this is your distance graph. The distance increase. So you can see from distance graph the power graph, the power column here, this third column is in equal increase. Equal increase. But for the column, the last column, X column here, the increase become bigger step. The step become bigger. Okay, from 0 here to here is 1, increase by 1. From here to here, increase by 3. From here, increase by 5. And then from here to here, increase by 7. From 3 to here, increase by 7. Then from here, as you can see, uh, the increase is getting bigger and bigger. So as you plot the graph of P against X, the P is equal. The power column increases equally, but the X column increases by a bigger step. So if you just without doing any calculation, just comparing how the steps increase, you know the answer is likely to be D. The answer is likely to be D because if you draw equal steps in increase here, you know, equal increment in P, you find that the steps in X actually become bigger and bigger. This step is smaller and increase bigger and bigger. This how you can get a graph from this column 3 and 4, right? By looking at the way the power in X changes with time. The power is equal increment with time, whereas X the increment with respect to time square. So there's a bigger step in increase. So therefore the answer should be D. But nevertheless, you can actually derive it mathematically. So if you want to use the power equation, power is F times V, right? But we also know that this F here can be represented as MA times V, right? Using Newton's second law, and V is actually can be obtained from remember the equation for kinematic. V squared is U squared plus 2AS. 2AS in this case, X is your distance, so your U is 0. So this V squared become 2S, and I can simplify this by taking square root of 2as, and I put this inside here, and that give me ma times square root of 2as. Now if every term is a constant, mass is a constant, acceleration is constant, m is constant, 2 is constant, a is a constant. So all the variables in front of s, all the symbols in front of s, actually all constants, right? It's like some constant multiplied by square root of s. So it's actually proportional to square root of s. The power is proportional to square root of s. So if you are familiar with maths equation, the graph, anything to do with anything higher power. This is let's say P. This is your S. This is proportional to x. This is maybe proportional to x square. This is proportional to x to the power of half, something like that. So again, this equation is consistent with this graph here. Okay, so the answer is D. Okay, so that's all for this question here.